Hello, students. How are you? I hope by now you had become friends with isomerism. If not, please go and check that particular videos. And now it's a time to get the friendship with nucleophilic substitution reaction. Although when it comes to IB, we say everything is important, but this is that most important topic which you should master for sure. Yes, this is one thing which you should master it very, very nicely. Both the nucleophilic reactions, SN1 also and SN2 also. So let's start doing it and let's break it easy. So let's begin. Nucleophilic substitution reaction. Okay. Now, what do you mean by nucleophiles? Let's break it into two words, nucleo and philic. So the word nucleo means nucleus, right? And the word philic means loving. That is nucleus loving. Now, who will love nucleus? What does the nucleus have? Nucleus have positive charge, right? Now, who will love positive charge? Negative charge. That means you can say nucleophiles are negatively charged species, right? Now, they're not just negatively charged, they could also have presence of lone pair. So basically, you can say in a nutshell that nucleophiles are electron rich species. Anything that has electron might be in the form of negatively charged or might be in the form of lone pairs. They are basically called as nucleophiles, right? Examples of nucleophiles will become, like if I give you a neutral example, ammonia, water. Now you will say, where are the nucleophiles? Ammonia and nitrogen has a lone pair, right? Oxygen has the lone pair in the case of water. So they are neutral nucleophiles which has a lone pair. Similarly, you can have anions in that particular example, which will include OH negative, Cl negative, etc. Right? So any anions which is having a negative charge or any species which is having a presence of lone pair can be treated as a nucleophile. Now, nucleophilic substitution reactions happens in halogenoalkane. Now, what do you mean by halogenoalkane? Halogen and alkane, right? Halogen is group 17, chlorine, bromine, fluorine, iodine. Alkane is CnH2n plus 2, right? So when alkane consists of one halogen at least, it becomes an halogenoalkane, like chlorobutane, uh, fluoropentane, anything. Any halogen is there. At least one halogen has to be there in an alkane. It becomes halogenoalkane. So I can say its general formula looks like CnH2n plus 1 X, where X could be chlorine, bromine, iodine. Fluorine can also be there. Fluorine is also a halogen. Acetine is also a halogen. Acetine is very down. It's very less reactive. Group 17, if you remember, down the group reactivity decreases, right? Okay. Now, let's talk about SN1. Now, what does S stands for? Substitution. N stands for nucleophilic. 1 stands for order of reaction. That means it is unimolecular. The key word that you will write down if they ask you what do you mean by 1 in SN1, so you will say it is unimolecular. Uni means one, just one molecule. Order of reaction is determined by just one molecule. Substitution, someone is replacing the other thing, and nucleophile we just now discussed. Now this halogenoalkane that we discussed could be of 3 types. You could have primary halogenoalkane, which you also called as 1 degree. You can have something as secondary halogenoalkane, which you basically called as 2 degree. You can have tertiary halogenoalkane, which is basically the 3 degree. What do you mean by 1 degree, 2 degree, and 3 degree now? So when you have a primary halogenoalkane, it means you have, let's say, a compound, and to this a chlorine is attached. So primary means my halogen is attached to a carbon, which is further attached to just one carbon, right? So primary halogenoalkane means a chlorine or any other halogen is attached to a carbon, which is further attached to just one carbon. So that means if my case is like this, now halogen is attached to a carbon, which is further attached to 2 carbons will become secondary. So that means now I hope you are able to understand and think of tertiary. Halogen is attached to a carbon, which is further attached to 3 carbons. That's a case of tertiary halogenoalkane, right? Now, SN1 reaction is shown by tertiary halogenoalkane. That means the one in which halogen is attached to a carbon, which is further attached to 3 carbons. Correct? Before we dive into this SN1 more importantly, let's do one more thing, which is called as basically carbocation. Now, this is primary, this is secondary, and this is tertiary halogenoalkane. We know that all these CH2, which is attached, the side CH3, which is there basically, they all are alkyl groups, right? They all are alkyl groups. Alkyl groups have a nature of donating electron. Alkyl groups, they have nature to donate electrons. That's why it is called that it is have a tendency to show plus I effect, where I stands for inductive. Now, this inductive word or plus I effect is not a part of our syllabus. Just the phenomena that alkyl have a nature to donate electron is called plus I effect. So someone is donating is plus. So if someone will take, will become minus automatically, right? So basically, if I make a tertiary carbocation like this, now we know that CCl is a polar bond, right? It's a polar bond, and they all three have electron donating nature because they all are alkyl groups. So what will happen? They will donate the electron and they will easily decompose the or break the compound, break, and a cleavage will happen over here. Heterolytic cleavage will happen, as a result of which the carbon is going to develop a positive charge. The carbon to which halogen is attached will develop a positive charge, right? In the case of secondary also, Being this polar, it is going to form this carbocation. And in the case of primary, you will have so this is primary, this is secondary, and that's tertiary. Correct. Now, in the case of primary carbocation, what is happening? You have alkyl groups, electron donating nature. So you are able to donate the electrons. So you can say that this positive charge is actually getting neutralized by just one end. A bit of the positive charge is able to get balance or neutralize a bit of stable by just getting the electron density, a slight electron density from one end. Over here, it is getting it from the two ends, whereas over here it is able to get it from the all three ends. So if you see, if you check it out, in the case of tertiary, since it is able to get it from all the three sides, it is more stable, right? Followed by secondary and followed by primary. So I can say my 3 degree is highly stable, followed by 2 degree and followed by 1 degree. So this is the stability of carbocation. What is a carbocation? A carbon containing a positive charge, right? When a carbon carries a positive charge, that's basically a carbocation, correct? So now SN1 is being there in the tertiary halogenoalkane. So let's see it. Let's take an example of this compound only. Right? So since this being a polar bond, what will happen? It is going to get dissociate and form a carbocation. This is the slow step. Step number 1. So whenever you get a tertiary halogenoalkane, the very first step that it undergoes for a reaction is it dissociates and it forms a carbocation. Right? Now in the step 2, this particular carbocation is attacked with a nucleophile and a nucleophile is going to go and make a bond. Right? Now, this nucleophile could be anything, like it could be any other halogen, it could be OH negative or something, anything, right? So let's say you have to do it for OH negative only. So this would have been CH3, C, CH3, CH3 positive, reacts with OH negative. Please keep in mind, arrow will go from the lone pair to the positive charge, will attach CH3, C, CH3, CH3, OH, right? Plus Cl negative is released. Correct? So when you have to draw an SN1 mechanism, the thing that you need to keep in mind while drawing it, firstly is this arrow. You have to show this arrow very, very carefully. You cannot miss this particular arrow. This is very important. Then this is a slow step reaction. Over here, you show this particular carbocation with this negatively charged ion. Then followed by this, show this positive charge on the carbon very clearly. Lone pair with the negative charge on the nucleophile. This arrow has to be there. And finally, the overall attack with the negatively charged ion. Everything has to be there. This is a fast step reaction and that's a slow step reaction. So SN1 reaction carry forward in two steps. One is slow and one is fast. Now, you know one thing, that when any reaction happens in a multi-step reaction, then the slowest step is the rate determining step, right? So in that particular case, my step 1 becomes the rate determining step, right? Now, in this step 1, I just have the halogenoalkane over there, right? Nothing else. So when I write down the rate expression, I can say rate is equals to K concentration of what I would say C1, 2, 3, 4, H is 9, Cl. Correct? Since it is just one molecule, that's why it was SN1 unimolecular. Question ask you, determine the rate, write down the rate expression for SN1 or SN2. They can even ask you write down the constant K SI unit. So how you write down? For rate, the SI unit is mole per dm³ per second upon concentration, which is mole per dm³ is equals to the value of uh, SI unit of K. So mole per dm³ cancel out mole per dm³. So K is just having the SI unit per second, right? Any questions, any doubts? Perfect. Let's go to SN2 reaction now. Now again in this, S stands for substitution. N stands for again nucleophilic. And 2 stands for second order reaction. That means it is bimolecular. Bimolecular means two molecules are determining the rate of a reaction. Correct? Now, SN2 reactions happens in primary halogenoalkane. Now, primary was in which the halogen is attached to a carbon, which is further attached to just one carbon, right? So let's take an example. That's your primary halogen. What I will do, I will first make a 3D geometry of this. So I have this carbon attached to two hydrogens. Then it is further attached to the CH3, CH2, C2H5. And I will keep this chlorine on the right hand side or on the left hand side. So let's say, let's keep it on the right hand side. This is H. Right? I can even make it properly using wedge and dotted dashboards. So how it will look like? This is H. This is Cl. This I will make H and this will become my C2H5. Correct? Now what happened? You are trying to react a nucleophile to it. Correct? This is itself a nucleophile. Chlorine is electron rich, so it is a nucleophile. When you will try to attack it from here, it will not attack. Why? Because the electrons of chlorine will repel the electrons of chlorine. So in the case of SN2 mechanism, The nucleophile will never come from the front as usual, the way it comes in all other reactions. So that means it is coming from the back end. One and the very most important thing of the reaction. Please keep in mind in SN1, the reaction happens from back end and not from the same side. So very first arrow that you will show is from CCl bond. This is polar. Let's make it for OH only, right? Now, I have to show like this. If I show like this, that's also fine. But the best and the better way, I will suggest you, oxygen is having that lone pair, right? So make over here an H on the other side, lone pair electron. Now make the arrow from here to the carbon. Don't end up the arrow to any bonds or something. Your arrow has to be very clear, going from the arrow towards the carbon. What happens when it happens like that? This chlorine and OH, they actually intergo, make a bond, a partial bond, and they form a transition state. Correct? In this transition state, this negative charge is very important. Please put this in a square bracket. Don't make any other bracket for sure. Make these two lines dotted. No solid bonds will work out. These two arrow has to be very clear and the OH has to come from the back end, right? Now, finally, what you will show, you will break this particular compound, H. This is my OH, H, C2H5 plus Cl negative. So I have to show the Cl negative also as a byproduct. Please keep OH on the left hand side only. What happens? Student do everything at the end of this reaction, they write down OH like this. No, please don't do that. Because over here, what are you showing? That the nucleophile has attacked from the back, and we discussed the reason why it is attacking from the back, because it cannot attack from the front. It is having a steric hindrance because of the electron repulsion of both nucleophiles. So this reaction undergoes 100% inversion. What do you mean by 100% inversion? Initially, in your reactants, the nucleophile is on the right hand side. But when you come out with the product, it is getting out on the left hand side. It is 100% inverted. Yes or no? Now, this entire reaction is happening in one single step. It is not step one, step two. No, it's not a intermediate. It's a transition state over here that is being basically formed, which is not stable. Carbon cannot have 5 bonds. That's our partial bond which forms. So it's not a stable state which is going to form in between like in SN1. So over here, it's a single step reaction. So the rate of reaction, for this reaction to happen, you need this nucleophile and this halogenoalkane entirely. So the rate will be K, concentration of OH negative and the concentration of C3H7Cl, right? Since they are two molecules, that's why it becomes what? Bimolecular, right? So in this case, if you have to find out the SI unit of K, it will be rate is mole per dm cube per second divided by mole per dm cube into mole per dm cube, right? So one cancel out. So it will become mole raised to the power -1 dm cube and second raised to the power -1. Yeah. So please don't learn or fix out anything. It will change as per equations to equations. And I hope you are able to analyze and figure out the SI unit using these particular formulas instead of directly mugging it up. Yeah. So we'll stop over here. Please practice the mechanism. This arrow movement is very important. These are the only areas which actually gives you marks when it comes to mechanism. I will upload one more video on this in which I will show you how to do the questions and how the questions are being asked on these two particular topics. Till then, take care and have a good day. Bye bye. And don't forget to subscribe the channel.